Assalamualaikum and hello everyone. We are from group AS1143A1 and today we will be presenting our project for CSC126, which is Fundamentals of Algorithms and Computer Problem Solving. Our project title is Student Expense Tracker System and supervised by our beloved lecturer, Dr. Tuan Nur Hafizah binti Tuan Zakaria. Our group members are Nurul Hurin binti Awang Ismail, Nurul Amir Adila binti Hazari, Nur Aiza Safia binti Zainuddin, and me myself, Nur Iza Akila binti Muhammad Zaharuddin. This project is a C++ console-based application designed to help students manage their daily expenses effectively. Users can input an amount spent and select a category such as food, transport, or bill. The system then stores these entries, calculates the total and average spending, and highlights the highest and lowest expense categories. It also features a menu-driven interface with options like Add Expense, View Summary, List All Expenses, and Exit, making it simple and user-friendly. We applied arrays to store data as well as functions, selections, and repetition control structures to manage the program's logic. More than just an assignment, this project has helped us understand how algorithms apply in real life while also encouraging better financial awareness among students. Before I pass it on, I just want to reflect a little on what this project means for us. As a student, I know how hard it is to keep track of small daily spending. We might think it's just 5 ringgit for food or it's just 3 ringgit for a drink, but when we add everything up, it becomes a lot actually. That's why we felt this system is not only useful for the cost requirement, but it is also something meaningful because we actually understand the problem we are solving. Personally, this project helped me better understand how coding can really be applied to solve real problems, not just theoretical ones. It has also taught me how important clean, modular code is in making programs that are easy to maintain and expand. From initial design to final testing, we followed a structured development approach which made collaboration easier and improved our outcome. Now, I will pass the presentation to Amira, who will explain the objective of our project.
Thank you, Iza. Now I will explain the objective of our project. The first one is to provide a simple, practical tools for students to monitor their daily expenses. The second one is to apply algorithm problem solving to a real-life financial situation. The third one is to build a complete C++ program using array, function, selection, and repetition. And lastly, to improve teamwork, communication, and project collaboration among members. Other than that, many students spend without tracking, so our system aims to fill that gap and help them become more responsible financially. These projects are also tested our understanding of programming logic and a real-world application. Through this, we realize how important planning is when it comes to building a working system. From identifying the problems to breaking it down into a smaller part, everything had to be through carefully. We also learned that no matter how small a system may seem, it needs attention to detail, especially in logic, validation, and user experience.
Thank you. Now I will present the flowchart of our system. The flow starts with a menu display where the user chooses 1. To add expense, 2. To view summary, 3. To list all expense, and 4. To exit. Each of these options is represented as a decision in the flowchart. The flowchart helps us map out the user journey through the programs. It starts with a start symbol, then moves to a display menu. Based on the user choice, the flow split into different paths. For example, if the user selects option 1, which is add expense, the system checks whether there's still space in the array. If yes, it proceeds to request the amount and category, stores them, and returns to the main menu. If option 2 is chosen, which is view summary, the system calls function to compute and display the total, average, highest and lowest expense. The flow then returns to the menu. This structure diagram makes the logic easier to visualize and ensure that the control flow is always correct. The exit options lead to the terminations of the loop and program ends. The flow continues until the user exits. So, our pseudocode starts with a do-while loop. If the user chooses an expense, the system checks if the array is full. Then, store the amount and category. If view summary is selected, it calculates total, average, finds highest and lowest using a for loop and conditional logic. This step-by-step designed to help us translate the logic into code smoothly. We also learn how to design logic before coding and make it understandable and error-proof. Pseudocode helps us to stay on track during development, and the flowchart was essential for visualizing how the entire system works before writing the actual program.
Thank you, Aiza. I'm Hurin and I will walk you through our C++ source code. We use two arrays, which is expenses and categories, to store user input. The code has three main functions, which is add expense, view summary, and list expenses. The program starts with a menu loop using do while and handles user choices using if-else or switch case. Next, in add expense, we collect and validate user input. In view summary, we calculate total and average and find the maximum or minimum expense using helper functions. All functions are modular and we use parameters where needed, matching what we learned in class. The user can also test different scenarios, for example, entering more than 3 to 5 expenses in various categories. The system will continue storing and updating results accurately, thanks to how we structure our loops and arrays. If the user tries to exceed the maximum number of entries, the program will notify them that the limit is reached. This helps avoid crash and shows how we implement basic input validation. We also applied the use of constant and validation to avoid exceeding array size. One thing I personally learned during this process is how important it is to test each function individually before combining them. It helped us avoid bugs and made debugging much easier later on. We use simple logic, but we organized it in a way that could easily be scaled or expanded. Hi everyone, in this video I will explain the source code and show a demo of our project, which is the student expense tracker system. Let's start with the code explanations.
At the top of our program, we declare two arrays, which is expenses, stores the amount of each expense, and categories, stores the corresponding category like food or transport. We also declare a constant called max entries, which limits how many records the user can add. This helps us avoid memory overload. Next, we define a few functions to handle different tasks in the program. The first one is add expand. The function prompts the user to enter an expand amount and a category. It then stores that data into the arrays and increases the total entries counted by 1. The second function is view summary. It first calculates the total expenses by looping through the array, then it computes the average by dividing the total by the number of entries. It also identifies the highest and the lowest expenses by comparing the value in the array and tracking their position. The third function is list expenses. It simply prints out all the stored expenses and their categories in order. At the bottom of the code is the main function. This is where the menu is displayed using a loop. The user can choose from option 1 to 4, and based on their input, the corresponding function is called. Okay, now let's run the program. First, the menu appears on the screen with 4 options. 1 is add expand, 2 view summary, 3 list all expenses, and 4 exit. I choose option 1, which called the add expense function. The system prompts me to enter an amount, so I type 10 ringgit and then I enter the category. I type food. Then I choose option 1 again to add another expand. This time I enter 7 ringgit 50 cents for the amount and the category is bill. Now I choose option 2 to view the summary. This runs the view summary function. The output shows total expenses is 17 ringgit 50 cents. Average spending is 8 ringgit 75 cents. Highest expense 10 ringgit under food and lowest expense 7 ringgit 50 cents under bills. As you can see, the program works correctly. It records each entry, calculates the correct totals, and identifies the highest and the lowest spending. This system is especially useful for students who want to monitor their daily spending and build good financial habits. That's all for the demo. Thank you.
Next, I will explain the control structures used in our system, specifically the use of if, while, do while, and for loops. First thing first, let's start with the if statement. We use if statement in multiple places to make decisions. For example, when the user enters their choice in the menu, we check whether the input is valid or not. We also use if to check whether the number of entries has reached the maximum allowed or if there are no expenses yet, and this will help prevent errors and guide the user properly. Next, the do while loop is used in our main function to repeat the menu until the user chooses to exit. This ensures that the menu is shown at least once and continues looping as long as the user has not selected the exit option. It is a perfect choice when we want to run a block of code first and check the condition of the word. For the while loop, we use it indirectly inside other features, like when we want to validate inputs, although this project we use do while more prominently for looping. Lastly, we use for loops in a few places. One of the most important is in the summary and list expenses functions. The for loop is ideal here because we need to iterate through all expenses and we know the exact number of of entries. It helps us to calculate the total, average, and also to find the highest and lowest expense. In summary, the combination of these control structures, which is if, do while, and for loops, helps us manage the flow of the program effectively, making it interactive, user-friendly, and well-organized.
Now, let me show you some example of input and output. In this sample, I added two expense, which is 12 ringgit for food and 6 ringgit 50 cents for transport. When I selected View Summary, the output display total 80 ringgit 50 cents, average 9 ringgit 25 cents, highest 12 ringgit for foods, and lowest 6 ringgit 50 cents for transport. This output shows that our program performed the correct calculations and categorizations. We also confirm the result using manual calculation to ensure accuracy. This gives confidence that our functions are working correctly and the logic is implemented properly. It was also helpful to test a variety of cases to see how the program handled different input and whether the summary would always display the correct results.
Now, let me talk about the possible improvements that we could apply to our student expense tracker system in the future. First of all, currently the data is only stored temporarily in memory. Once the user exits the program, all recorded expenses will be lost. So, one of the biggest improvements is to implement file handling, which allows users to save their data into a text file or read from it the next time they open the system. This would make the system more practical and useful in real-life situations. Secondly, we can improve the user interface by creating a more interactive menu. For example, we can use color-coded output or a graphical user interface using external libraries such as SFML or Qt. We could also add more advanced features like filtering expenses by date or category, setting monthly limits, and sending alerts when the user is close to overspending. Another possible improvement is to calculate the trend of expenses over time and display charts or summaries using a graphics. This will help the user understand their spending habits more visually. Lastly, we can enhance security by adding login and logout features so that different users can track their own expenses separately. Each user will have a username and password, and the expenses will be stored in individual files. These are some of the potential enhancements that we plan to add if we were to further develop this student expense tracker system project.
In completing this project, we learned how to solve real-life problems using a structured program techniques. We practice breaking down the problems into a smaller task using a function, array, and loop effectively. Each group member contribute to different parts such as designing a flowchart, writing codes, and testing the logic, which can improve our teamwork and communication. Furthermore, we also had to manage our time and coordinate through online discussion. This taught us how to work efficiently in a team and balance technical and communication skills. And lastly, in conclusion, a student expensive tracker system helps us to apply what we have learned in a CSC126 to a meaningful use case. The project gave us hands-on experience with C++ programming and also encouraged us to think critically about financial literacy. Not just that, we believe that this system could be developed further in a future with features like file saving, report generation, or even a mobile app version. So, thank you for listening to our presentation.